Welcome to Unit 3, Operations with Fractions. In this unit, you'll learn to estimate the products and quotients of fractions and mixed numbers, multiply a fraction by a whole number and by a fraction, divide a fraction by a whole number and by a fraction, multiply and divide mixed numbers, and use the order of operations with fractions. Topic 3.1, using models to multiply fractions and whole numbers. How many ways can you find this sum? You could probably find the sum several ways. You could count by fives, 5, 10, 15, 20, and so on. You could count the number of fives and then multiply that number by 5. Or we could use a bank model and enter sets of 5 counters into the bank to figure out how many we would have in the end. Take this problem, for example. Each of 4 students needs 5/6 of a bag of oranges to make a pitcher of freshly squeezed orange juice. Now, each bag of oranges contains 12 oranges. How many bags of oranges are used? Well, we know that there are going to be 4 students involved in this problem. So part of the model could just be simply representing 4 separate students. And what I'm going to do also is I'm going to draw a bag of oranges for each student. Now you may be thinking, wait a minute now, each student doesn't have a whole bag. And you're right, each student actually only has 5/6 of a bag. So what we can do is we can actually divide each of these bags into 6 separate parts, okay, to represent the sixths of each of the bags. Okay, now each student needs 5/6 of a bag, correct? Right. So what we'll do is we'll actually shade in 5/6 of this bag. That's what this student needs. And we'll do the same thing. I'm just going to save a bit of time by shading in all 5 of them at the same time here for the next 3 students. Okay, so each of these 4 students, pardon me, has 5/6 of a bag of oranges. Now, how many bags of oranges are used in total? Well, neither of these are actually full bags. None of them are. So what we want to do is account for this missing sixth, this missing sixth, and this missing sixth. And we can actually take these 3 over here, 1, 2, and 3, to do that. So we'll take number 1 over and fill in this one. We'll take number 2 over here to fill in this one. We'll take number 3 over here to fill in this one. So what I'm going to do to show you what I mean is I'm just going to now shade this one in black. So this is now gone. These 3/6 are now gone from this model. So this bag is only actually 2/6 full. So the question was, how many bags of oranges are used? Well, we've got 3 full bags, okay, and 2/6 of another bag, or 1/3. Now we can show that same problem, 4 times 5/6, in a slightly different way. Very similar, but slightly different. We can draw a larger rectangle, okay, and divide it into 4 equal parts. Okay, now each of these parts represents each of the 4 students. All right? We're just doing it this way rather than showing stick figures. Now, to save a bit of time, you can divide up each of those parts all at the same time. Into sixths. Okay, we use the denominator of this fraction to find out how many parts of a whole we have for each student. And then we can follow the same procedure. So we can shade in 5 of the sixths. To find our answer. And again, we'd want to take these 3 parts over here to fill in these 3 parts that are missing over here to find our answer. So our answer would be the same, of course, 3 and 2/6, which can be simplified to 3 and 1/3. We can also use a number line to represent this problem. So the 4 numbers I have here on the number line actually represent the students. And each one of these can be divided into sixths, okay, and we can simply just take steps. Now each step is going to be 5/6. Okay, so our first step is going to be to here. Our second step will take us to there. Third step will take us to there. And our fourth step will take us to 3 and 2/6, or 3 and 1/3. So there are a couple of ways that you can model multiplication of whole numbers and fractions. Let's take another problem. 21 times 2/3. What I've done is I've used the rectangle model here. I've divided it into 21 even vertical spaces. And I'm going to divide up all of those 21 individual spaces into thirds. It's going to look like this. Each one of them now has 3 even parts. And I'm going to shade in then I'm going to shade in 2/3 of the entire thing. Okay, representing 2/3 of each of those 21 parts. And then I'm going to start filling in these blank spaces to find out what our answer is. So for example, I could take these 2 shaded in thirds, and I could color in these 2 over here. And I could take, let's say, these 4 over here, and I could shade in these 4 over here. And I'm just going to continue going like that until I run out of spaces, of shaded thirds to fill in the empty spaces. So we'll take, say, these 2 can fill in these 4 can fill in these 4, and let's see, these 2 here can fill in these 2. So it looks like I'm done. I've actually removed all of these here to fill in the empty spaces in the other parts. So our answer is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Now we can also solve this problem using a number line. And we would do that by taking 21 steps of 2/3 each. So now these step sizes right now, these are whole numbers. So what we need to do is divide each of the whole numbers into thirds so that we can now take steps of size 2/3. So I'm just simply dividing each whole number into 3 separate parts, or 3/3. Now we're going to take 21 steps of 2/3. So our first step would be to here, be your second step, third, fourth, fifth, sixth, seventh, eighth, ninth, 10th, 11th, 12th, 13th, 14th, 15th, 16th, 17th, 18th, 19th, 20th, and 21st. So that is 21 steps of size 2/3, and we end up at 14. There is one other way to solve this problem, and that is by using the bank model. So what I've done is I've got a bank model here, and I've deposited 21 counters into the bank model. And I've gone a step further and divided those 21 counters into 3 even groups of 7. The reason why I did that is because I want to know what 2/3 of 21 is. So having 21 divided into thirds, or divided into 3 separate groups, helps me do that. Then I just need to take 2 of the thirds, lump them together, and I've got my answer. So you can simply take 2 of the thirds, group them together, and get your answer. 2/3 of 21 is equal to 14.